Okie dokie, people from Muskogee. We have our 6th question warm up here from chapter 7. We haven't really actually started the questions of 7, but these are kind of things you need to be able to do, except for the last 3 questions are kind of the basic questions that we did in our notes. But the first 3 questions are reach back to things that would be important to be able to rationalize some of the questions within 7.1. So our first question, by the way, if you're trying this on, press pause, try the questions, listen to the answers. Our first question is from our exponents law unit. It says the division of x to the power of 5 divided by x to the power of 3, same base. The law says if you have a power with the same base, you can keep the base, subtract your exponents. So therefore, the simplification of that would simply be x to the power of 2. In our second question, as an area is given of a rectangle, 8 is the length, x is the width. It says solve with the formula a equals length times width. So if we have the formula area equals length times width and the area is 24, I can substitute the number 24 for where the a was in my formula. Since the length of this particular triangle is 8, I can put 8 for where the length is. Oh, I better take my green highlighter and say that's where the length is. And the width, a different color highlighters that do blue, is w, so therefore I can leave it as x. When I substitute the information into my equation, I get 24 equals 8x, which Dawson McCausland, who's excellent at algebraic equations, would tell you that if you divide both sides by the coefficient in an algebraic equation, you will isolate the variable, and you'll end up with the width is 3. That's an important, I mean, that's a question that's not a grade 9 question. That's a grade probably 7 question. But you should be able to understand that that's how you solve that question. Likewise, in this particular question, we actually worked yesterday on developing this formula, and I want to show you where this formula came from just real quick. Area of a triangle is equal to base times height divided by 2. Now, algebraically speaking, you have to remember the idea in grade 7 you learned about balance. That equal sign talks about balance. The area of a triangle will be equal to taking the base, multiplying it by a height, and dividing by 2. That's easy peasy, lemon squeezy. If I was to start to rearrange this equation, and if I was to multiply this side by 2 and multiply this side by 2, keeping the idea of this equation here, if I was to multiply both sides by 2, I would still maintain equality, but I would end up with a different equation. I'd have base times height equals 2 multiplied by the area. That formula is still equal to each other. Multiplying the area by 2 in a triangle will be equal to the base times the height. And then if I wanted to get this particular variable isolated, if I wanted h to be by itself, if I look on that right-hand side, I have base times height. So if I divide, because I'm multiplying by if I divide by the base and divide by the base, I should understand that that isolates the variable. Just like if I was taking 2x and divided it by 2, in this case, the coefficient really, I can consider the coefficient to be b. Dividing both sides by b will give me this beautiful, lovely, wonderful formula, the one I gave you right here. So I just want to make sure you understand where that formula comes from. It's not a complicated thing. It's just that's where it comes from. So that's the formula we're given. And we're given a triangle. The base is 12. The height is unknown, but the area is 48. So again, I'm going to take I'm going to delete this here first, my highlight. And I'm going to substitute everything in. So I'm going to start with let's go with the area. The area is 48. So in my formula, h equals 2 multiplied by 48, divided by the base, which is 12. So when I substitute all the information into my formula, I end up getting an already isolated h. All I have to do is simplify that right-hand side, and I get my value. So h equals, well, 2 times 48 is 96. And 96 divided by 12, how many 12s? There's 8 of them. So therefore, the height in this particular triangle would be 8. So again, 12 times 8, base times height is 96, divided by 2 is 48. The fourth question takes us into chapter 7.1. It's multiplication of a monomial by a monomial. And we learned 2 different ways. The first way is to use the associative property of mathematics. So I'll just call it the property of math. The associative property of mathematics. because 2x plus or times 5 means 2 multiplied by x, that's what 2x means, multiplied by 5 multiplied by x. The associative property says the order in which we multiply them does not matter, so we can rearrange those terms to do this, which will end up becoming 2 times 5. When you multiply the coefficients, you get 10, but when you multiply an x by an x, you end up with x squared. So when I solve it that way, I end up with 10x squared. Now the second way you could do it is what we call the area model. I have a length and a width done here. I'm going to draw the length and the width of a rectangled field. On one of them, I'm going to do 2x. So I'm going to do 1x, 2x, and there's positive, so I'll shade them in as positive. That is 2x. The width or the length is going to be 5x, so 1x, 2x, 3x, 4x, 5x. Shade them in because they're positive. So now, if I grab a black marker and shade that whole bad boy in, that black rectangle has a length of 5x and a width of 2x, and its area, or what's going to be inside it, will be the product of 2x and 5x. So I'm going to draw a line here, and now I can see the area as being 10x squared. So these are going to be positive x squareds because it's a positive x and a positive x and a positive times a positive is a positive. So we can see from the interior of that the product of 5x and 2x is 10x squared. Is this our fifth question or sixth question? Fifth question. Now we have the division of a monomial by a monomial. And if we think about what this could be, if I gave you a triangle with an area of 10 and a width of 5, the area divided by the side I know will tell me the side I don't. So therefore, this idea, a number divided by another number gives you the missing number, is what this is really about. So you could draw it. We're not going to draw it right now. We're just going to say, remember that 8x squared divided by 4x can mean, if I reverse it, 8 over 4 multiplied by x squared over x. And if I had this question, you would get this answer. If I asked you to multiply those two fractions together, you would get this answer. So I'm reversing kind of like fraction multiplication. But of course, if you had this, you would never do 8 over 4 because that would be unnecessary. You could actually reduce that down to 2 over 1. And x squared divided by x, if I use my sign laws, x squared divided by x, same base, keep the base, subtract your exponents, you would end up with just x. So this would end up with just being x, or x over 1, if you want to think of it that way. And now that I reversed, I solved that, I would have multiply the numerators. 2 times x is 2x, 1 times 1 is 1. So my final answer of what is 8x squared divided by 4x, the answer is 2x. I know it's a little bit complicated, but what I would have done if this was the question and you get really better at it, which you would be doing here eventually, is saying, okay, I remember that that's 8 over 4. I remember this. And all you would be doing is you divide your coefficients first and do this. You divide this part here and you get x, and you'd see your answer as being 2x right away. You wouldn't have to do all of this rigmarole here. You'd know how to do it. And finally, our last question is basically the same thing as this. That's the same question, except different numbers and different things. So the area is given. And what is this area in the middle here? What does that say? That says negative 9x squared. That's the area. So the area divided by the side that I know, which is, in this case, positive 3x, will equal the side that I don't know. Now let me ask you a question. If I fill these in, I can fill them in here, right? Are those going to be positive or negative x's? They're going to be negative because a negative times a positive gives me this negative x squared that's in the middle there. So therefore, if I look at the picture, what is my missing side length? Negative 3x. And that is what that picture says. It says negative 9x squared, the area, divided by the side I know, which in this case is a positive 3x, equals the side I don't know, which in this case would be negative 3x.